Imagine looking through the world's most powerful telescope, peering 13 billion light-years across the vast, dark ocean of the cosmos, and seeing something that feels like finding a smartphone inside a dinosaur fossil. For decades, our understanding of the universe has been built on a very specific set of rules, a chronological script that tells us exactly how stars are born, how they age, and what they are made of. But a team of astronomers has just identified a star, officially catalogued as SMSS J0313-6708, that is currently shattering every single one of those laws. It is a star that is so ancient it was likely born shortly after the Big Bang, yet its chemical composition contains elements that shouldn't have been forged for another billion years. It is a celestial anomaly that exists in a state of impossible contradiction, a Methuselah star that appears to be older than the universe itself based on our current mathematical models. The physics community is in a state of absolute disbelief because if this star is real, then our entire timeline of how galaxies and heavy elements were created is fundamentally wrong. Today, we are embarking on a journey across the light years to uncover the mystery of the star that shouldn't exist, why it is breaking the fundamental laws of astrophysics, and how a single point of light in the Southern Cross is forcing us to rethink the very origin of everything. To understand why this star is a scientific hand grenade, we first have to talk about the cosmic recipe book. According to the standard model of cosmology, the early universe was a very simple place. Just after the Big Bang, there were only two main ingredients, hydrogen and helium, with a tiny pinch of lithium. There was no iron, no carbon, no oxygen, and certainly no gold. In fact, astronomers call everything heavier than helium a metal. The very first stars, known as population 3 stars, were massive, hot giants made purely of that primordial hydrogen and helium. These stars lived fast and ended in spectacular explosions. And it was only inside those explosions that the first metals like iron and magnesium were forged and blasted into space. This means that every generation of stars that followed should have more metal than the one before it. It's like a cosmic ledger. The more polluted a star is with heavy elements, the younger it must be. But SMSS J0313-6708 refuses to follow the ledger. When researchers analyzed its light spectrum, they found something that made them check their instruments 10 times over. The star has virtually no detectable iron. We are talking about an iron level that is less than 1/10,000,000th of the iron found in our own sun. By all standard definitions, this should be a population 3 star, one of the very first to ever blink into existence. However, it contains significant amounts of carbon and magnesium. According to every model we have, you cannot get that much carbon without also having a corresponding amount of iron being produced in a supernova. It is like finding a cake that has been baked with sugar and flour but somehow contains 0 calories. The chemistry just doesn't add up. The discovery was made using the Sky Mapper telescope at the Siding Spring Observatory in Australia. This telescope was designed to hunt for the oldest stars in the Milky Way, but no one expected to find something this extreme. The star is located about 6,000 light-years away, which in galactic terms is practically in our backyard. The fact that an impossible relic from the dawn of time is sitting right here in our galaxy is a shock in itself. It's like finding a pristine, functioning ancient Egyptian chariot parked in a modern suburban garage. It shouldn't have survived the billions of years of galactic mergers and star formation that built the Milky Way. So how do the laws of physics explain a star with carbon but no iron? Right now, they don't. The leading patch for this hole in our knowledge is a theoretical event called a low-energy supernova. Some astrophysicists suggest that the very first stars were so massive that when they collapsed, they didn't just explode, they partially imploded. In this scenario, the heavy iron core of the dying star was swallowed by a black hole that formed at its center, while the outer layers, rich in lighter elements like carbon and magnesium, were sneezed out into space. This sneezed material then collapsed to form the star we see today. But even this theory is on shaky ground. The precision required for a black hole to swallow exactly the iron and leave exactly the carbon is so high that it feels mathematically improbable. It's a fine-tuning problem that makes scientists very uncomfortable. But the mystery goes even deeper. When astronomers tried to calculate the age of this star using the most advanced cosmic clocks, they ran into a brick wall. Most stars are dated by their lithium content or their position in a cluster, but SMSS J0313 is a lone wolf. When they applied the standard formulas for stellar evolution, the results kept coming back with an age of over 13.7 billion years. The problem? The universe is only about 13.8 billion years old. While that technically fits, it leaves almost zero time for the first stars to form, live their lives, explode, and for this second-generation star to condense from the debris. It's a timeline so tight it leaves no room for the actual physics of gravity to work. It's like trying to build a skyscraper in 5 minutes. This age tension is causing a massive divide in the physics community. On one side, you have the observers who say the data is clear. The star is there, its chemistry is weird, and its age is ancient. On the other side, you have the theorists who argue that our measurement of the Hubble constant, the speed at which the universe is expanding, must be wrong. If the universe is actually slightly older than we think, the star makes sense. But if the universe is older, then our understanding of dark energy and the Big Bang itself starts to unravel. This one tiny star is pulling on a thread that could unspool the entire tapestry of modern cosmology. The technology used to analyze this star is a masterclass in modern engineering. To look at the chemical fingerprint of a star 6,000 light-years away, astronomers use spectroscopy. They take the light from the star and pass it through a prism to create a rainbow. But it's a rainbow with tiny dark lines in it. Each of those lines corresponds to a specific element absorbing light at a specific frequency. It's like a cosmic barcode. To detect the missing iron in SMSS J0313, researchers had to use the Magellan telescopes in Chile to get a high-resolution barcode that is so precise it can detect a single atom of iron in a sea of billions of other atoms. The fact that we can even have this debate is a testament to the incredible reach of human technology. But let's talk about the ghost star theory. Some researchers are wondering if the star we see isn't a single object at all, but a binary system or something even more exotic. What if the carbon we see isn't original to the star? What if it's polluting its surface by sipping material away from an invisible companion, a white dwarf or a black hole? If the star is stealing its chemistry, then our age calculations are completely off. The star could be a fraud, appearing much older and more primitive than it actually is. However, searches for a companion star have so far come up empty. As far as we can tell, this star is a solitary, impossible relic, standing alone in the dark. Why should the average person care about a distant ball of gas with a weird chemical mix? Because stars are the factories of the universe. Every atom in your body, the calcium in your bones, the iron in your blood, the carbon in your DNA, was forged inside a star like this one. If our model of how stars create these elements is wrong, then our understanding of our own biological origins is also incomplete. We are literally made of star stuff. And if the star stuff isn't following the rules, then the story of how we got here needs a rewrite. SMSS J0313 is a mirror reflecting our own ignorance back at us. The discovery has sparked a new hunt across the sky. Astronomers are now using AI algorithms to sift through millions of stars in the Gaia satellite database, looking for more of these impossible objects. If SMSS J0313 is the only one, it's a freak of nature. But if we find 100 of them, then it's a new law of physics. We are looking for metal-poor stars in the galactic halo, the outermost edge of the Milky Way where the oldest material resides. This is essentially galactic archaeology. We are digging through the layers of the galaxy to find the ruins of the first stars. There is also a fascinating magnetic component to this mystery. Some theorists suggest that in the very early universe, magnetic fields were much stronger than they are today. These fields could have prevented iron from mixing into the surrounding gas clouds, while allowing lighter elements like carbon to flow freely. If this is true, it means the early universe wasn't just a simple mix of gas. It was a complex, magnetized environment that shaped the first galaxies in ways we've completely overlooked. The star that shouldn't exist might be the first evidence of a magnetic dark age that happened right after the Big Bang. Let's think about the Methuselah aspect again. This isn't the first star to challenge the age of the universe. For years, a star called HD 140283 has been nicknamed the Methuselah star because initial estimates put its age at 14.5 billion years. Nearly a billion years older than the universe. Astronomers eventually fixed that by refining their distance measurements, bringing the age down to a more legal 13.7 billion. But SMSS J0313 isn't giving up its secrets that easily. Its chemistry is so much more extreme than the previous record holders that the distance fix doesn't solve the problem. Even if it's closer or farther than we think, the lack of iron remains an astrophysical impossible result. What if the Big Bang wasn't a single event but a series of ripples? A new, highly controversial theory called the Big Bounce suggests that our universe is just the latest in a series of expansions and contractions. In a bounce universe, some stars from the previous cycle could potentially survive the transition into the new one. This would explain a star that is older than the universe. It's actually a survivor from the previous universe. While this sounds like science fiction, some physicists are taking it seriously because it solves the singularity problem of the Big Bang. In this view, SMSS J0313 is an immigrant from another era of space-time. But back in the realm of more grounded physics, the discovery is forcing a massive upgrade to our supernova simulations. For years, we've assumed that a supernova is a relatively symmetrical explosion, but the existence of this star suggests that the first explosions in the universe were chunky and asymmetrical. They were messy, violent events that didn't distribute their elements evenly. This changes our entire model of how the first galaxies were seeded with the building blocks of life. It turns out the early universe was a lot more like a Jackson Pollock painting than a neat, orderly diagram. The sheer scale of this star's iron deficiency is hard to visualize. If you took all the iron in the sun and put it in a giant sphere, and then did the same for SMSS J0313, the sun's sphere would be the size of the Earth, while the other star's sphere would be the size of a single marble. Yet the two stars are roughly the same mass. This chemical void is a glaring signpost that we are missing a fundamental piece of the cosmic puzzle. There's also the lithium problem to consider. According to the Big Bang Theory, there should be a very specific amount of lithium in the oldest stars, but almost every ancient star we find, including this one, has much less lithium than predicted. This is known as the cosmological lithium discrepancy. The star that shouldn't exist is providing more data on this gap. Some think the lithium is being destroyed inside the star, while others think our Big Bang math is just slightly off. Either way, the star is a laboratory for the most extreme conditions humanity has ever studied. The researchers who found this star describe the feeling as terrifyingly exciting. In science, you usually want your data to confirm your theories. It's comfortable, but the greatest leaps forward happen when the data tells you that your theories are garbage. SMSS J0313 is that garbage-making discovery. It is a sign that the next generation of astrophysicists will have to invent new math and new physics to explain what we are seeing. It's an invitation to a new era of discovery. Think about the light-time connection. When we look at this star, we are seeing light that has been traveling through space for trillions of miles. That light left the star before the Earth even existed. It traveled through the void while the dinosaurs ruled the planet, and while the first humans learned to make fire. By the time it reached the Sky Mapper telescope, it was a faded, ancient whisper. And yet, in that whisper, we found a message that says, "You don't know as much as you think you do." The galaxy is much more complex than our simple models suggest. We tend to think of the Milky Way as a disk of stars, but it's actually a living entity with a complex history of eating smaller galaxies. SMSS J0313 is likely part of the galactic halo, a cloud of ancient stars that surrounds the disk. These stars are the ancestry of our galaxy. By studying them, we are doing a DNA test on the Milky Way. And what the DNA says is that our galaxy has a very strange and perhaps much older origin than we ever suspected. How does a star like this survive for 13 billion years? It's a low-mass star, much smaller than the giants that explode as supernovas. Because it's small, it burns its fuel very slowly. While the massive population 3 stars burned out in a few million years, these smaller population 2 stars can live for tens of billions of years. In fact, SMSS J0313 will likely still be shining long after our sun has turned into a white dwarf and faded away. It is a slow-burning ember from the dawn of time, a witness to the entire history of the cosmos. But the question remains, why haven't we found any population 3 stars? Why haven't we found a star with absolutely zero metals? Astronomers have been searching for decades, and they've found nothing. Some think it's because those stars were all so massive that they are all dead. But others think that maybe we've been looking for the wrong thing. Maybe population 3 stars look different than we thought. Maybe SMSS J0313 is the closest we will ever get, a hybrid that carries the secrets of the first stars in its carbon-rich atmosphere. This discovery is also a call to arms for the James Webb Space Telescope. While SkyMapper found the star in our own galaxy, Webb has the power to look at the first light of the first galaxies billions of light years away. By comparing the impossible star in our backyard to the first stars at the edge of the universe, we can see if the same rules, or lack of rules, apply everywhere. We are looking for a universal pattern of impossible chemistry. The physics community is also looking at dark matter as a possible culprit. What if dark matter isn't just invisible stuff that provides gravity? What if it interacts with normal gas in the early universe in ways that alter star formation? A dark matter star, or a star infected by dark matter, might behave exactly like SMSS J0313. It could burn at different temperatures and forge different elements. This would mean that the laws of physics aren't being broken. They are just being influenced by a shadow world that we can't see. Every time we think we've conquered the final frontier of space, a discovery like this reminds us that we are just beginners. We are like children looking at a massive ocean and thinking we understand it because we've seen a few waves. The impossible star is a reminder that there are deep currents and hidden monsters in the cosmic ocean that we haven't even begun to map. It's an exciting, humbling, and profound realization. The star is also a lesson in scientific humility. We spent the 20th century building a beautiful, logical model of the universe. We felt like we had nearly finished the puzzle. But the 21st century is showing us that the puzzle is far bigger than the table we were building it on. SMSS J0313 is a piece that doesn't fit into any of the holes we've made, and instead of forcing it to fit, we have to be brave enough to build a bigger table. In a world where we often feel like everything has been Googled and mapped, it is wonderful to know that there are still fundamental mysteries. There are still stars that defy us. There are still lights in the sky that hold the secrets to the beginning and the end of time. SMSS J0313 isn't just a star. It's a beacon calling us to keep looking, keep asking, and keep dreaming of the impossible. As astronomers continue to point their most advanced mirrors at this tiny point of light, they are doing more than just science. They are participating in an ancient human tradition. We have always looked at the stars and wondered where we came from. We have always tried to find order in the chaos. And even when the stars tell us that our order is an illusion, we don't look away. We lean in. We look closer. We listen to the light. The star that shouldn't exist is a testament to the power of the anomaly. In the history of science, it's always the anomalies that lead to the breakthroughs. It was the anomaly of the orbit of Mercury that led to general relativity. It was the anomaly of blackbody radiation that led to quantum mechanics. SMSS J0313 is the next great anomaly. It is the thread that, when pulled, will lead us to a more beautiful and correct version of the universe. So next time you are under a dark sky, look up. You might not be able to see SMSS J0313 with your naked eye, but it's there. It's a silent, stubborn witness to the Big Bang, a chemical rebel that refuses to follow the rules, and a glowing reminder that the universe is far more mysterious than we ever dared to believe. It is a star that has been shining for 13 billion years, waiting for us to develop the technology and the curiosity to find it. And now that we have, the real journey begins. The discovery is a reminder that we are part of a living, evolving story. We aren't just observers of the universe, we are a part of it. The carbon in your hand and the carbon in that impossible star are the same substance, forged in the same cosmic fires. By understanding the star, we understand ourselves. We find our place in the long, strange, and beautiful history of the light. As we conclude our look into this astrophysical enigma, stay interested in the fringes of science. Stay interested in the things that don't fit. Because that's where the truth is hiding. The star that shouldn't exist is a gift to the human mind, a puzzle that will take generations to solve. And in the process of solving it, we will discover more about our world than we ever thought possible. The light of SMSS J0313-6708 continues to travel across the void, carrying its impossible message to any civilization brave enough to decode it. We were the ones who found it. We are the ones who are listening, and as the laws of physics are rewritten in the coming years, we will remember the tiny iron-poor star that started it all. It is a star that shouldn't exist, and yet there it is, shining bright, breaking the rules, and inviting us to come and find out why. The cosmos is beckoning. The telescopes are turning. The math is being reworked, and the impossible is becoming the possible. It's an amazing time to be alive, and an amazing time to be looking at the stars. Let's keep looking, let's keep questioning, and let's never stop reaching for the impossible. Because as this star proves, the universe is much bigger, older, and weirder than we ever imagined. And that is the most stunning discovery of all. Stay curious, stay amazed, and always keep your eyes on the stars. The next impossible discovery is just around the corner, waiting for us to find it in the limitless dark of the great beyond.